Complex numbers made easy. What if I told you that mathematicians invented a number that literally doesn't exist and then used it to solve real problems? Sounds crazy, right? Well, meet the famous imaginary number I. Stick around until the end because I'll show you why this imaginary number is actually one of the coolest ideas in mathematics. And I've got a quick challenge waiting for you too. What's I? Imagine your calculator saying, "Sorry, I can't do that." That's exactly what happened when I asked for the square root of -1. But mathematicians were like, "Calculator, relax, we got this." So they invented a new symbol. I equals the square root of -1, and that gives us I squared equals -1. That's the only rule you absolutely need to remember. Square roots of negative numbers. Let's warm up. What is the square root of -49? Easy. Separate the positive part from the negative part. The square root of 49 times -1, which becomes the square root of 49 times the square root of -1. Square root of 49 equals 7, and square root of -1 equals I. Our answer is 7i. Square root of -49 equals 7i. That's it. Whenever you see the square root of a negative number, just remember, there is an I hiding in there. Quick question. Can you solve this? The square root of -64 equals what? Pause the video. Write your answer in the comments. No cheating. Complex numbers. A complex number looks like this. A plus bi. Think of it like a burger. The bun is the real part, the meat is the imaginary part. Together, that's a complete burger. Example, 5 plus 2i. Real part 5, imaginary part 2. Easy. Complex plane. Regular numbers live on a number line. Complex numbers wanted a bigger apartment. So they moved into 2 dimensions. The horizontal axis is the real axis. The vertical axis is the imaginary axis. For example, -2 plus 3i, move left 2, go up 3. Done. Adding complex numbers. Let's add -3 minus 5i plus 4 plus 2i. Combine the real numbers. -3 plus 4 equals 1. Now combine the imaginary parts. -5 plus 2 equals -3. Final answer, 1 minus 3i. Multiplying, let's multiply. -5 times 7 minus 3i. Multiply every term. You get -35 plus 15i. Easy! Now here is where students usually panic. Don't panic, we've got a secret weapon. It's called the complex conjugate. If you have a plus bi, its conjugate is a minus bi. Just change the sign. That's all. Why does it work? Watch. A plus bi times a minus bi. Expand it. The imaginary terms cancel. You get a squared plus b squared. Dividing complex numbers. Mission accomplished. General formula. Suppose we want to divide the fraction a plus bi over c plus di. Multiply the numerator and denominator by c minus di. After simplify, we get the fraction ac plus bd plus bc minus ad times I over c squared plus d squared. Now the denominator is a real number. Nice and clean. Quick review. Let's recap. I equals the square root of -1. I squared equals -1. The square root of -a equals the square root of a times I. Add like terms. Multiply normally. Divide using conjugate. Complex numbers aren't so complex anymore. Ending. If today's lesson made complex numbers finally make sense, give this video a thumbs up. Here is my question for you. Which part used to confuse you the most? Imaginary numbers, multiplication, division using conjugates? Tell me in the comments. I'll read every one of them. If you're serious about mastering algebra, trigonometry, calculus, you are in the right place. Don't forget to subscribe, turn on the notification bell, grow in math community, and join us. Thank you for watching, and remember, math isn't about being a genius. It's about learning one clever idea at a time. See you in the next lesson.